Only thing to remember, you have to be close to the microphone. Then only everybody can hear you. You're on record.
Our minister, Vishnu.
What's the name of your team?
What's that? I1 AI.
Team name?
I1 AI. Sharing.
You need to plug in, right? Or you log in, right?
Yeah. See, there it is coming in, but
Okay.
not there. I'm sharing because I could see that. See there?
I think this screen need to switch actually.
Yeah. How to switch?
Let him.
Let Asif come. Asif,
You need to
I'm
switch
here.
the screen.
The screen.
What you do is, are you on Zoom?
Yeah. You could see that mine is mirrored
Okay.
there.
Okay. I'll bring it here.
Oh, there.
Oh, you need to switch. Screen.
Hello, everyone. So this is the project which we did for phase 3. So basically semantic search. So I'll just give an overview what we did. Oh, okay. Am I audible now? Okay. Okay. So basically what we did was we took the complete works of. Am I audible? Yeah. So we took the complete works of Shakespeare document, and what we did was we did 3 steps. So one was in terms of doing a paragraph splitting using the Brook chunking. And then what we did was feed the chunks into a semantic chunk algorithm, which we developed on our own. It is like a way where we used cosine similarity. I'll go through that. And third is save them to the database, which we used a SQLite because it was a easily available one. And also for caching purposes, if you remember last time when we tried to do a search, it took such a long time. So what we did was the search corpus embeddings, we wrote to a pickle file. So basically it served as a cache so that we could get it very quick, right? So the first one is, you see, this is the file URL. So we download it. And we remember that when we downloaded first time in Project Gutenberg, we had a lot of superfluous information on top of like contractual stuff and everything. So Project Gutenberg has a token which starts like start and end. So whatever between these markers is the actual document. So that way we don't have to, do unnecessary chunking. And because by this we saved close to 9,000 paragraphs. So we had like originally when we did a paragraph splitting, it came to 49K tokens. And when we went with this actual meet, it was like 40K, right? Yeah, that is where. So prior to that, you would see that a lot of unnecessary language, and post end, you will see a lot of this contractual stuff, which we don't need actually. No, this is the one. This is the util ASIC. So what I did was, for example, here we download it, and then the text, we extract the text, you see, between this markers and write it back. And then comes the convert to chunks. So this is the brute force chunking where we split it double lines, right? Double new lines. So that what it means, like it's a paragraph, right? And so I have this utility, since it's a file util, I have this save to pickle and pickle data. Thanks, as last time you pointed out in the review, and this really helped. And so this will serve as a cache for us. And next I'll go to the actual one. So you would see the search corpus module here. Actually, this is the first phase 1. Why it is here, I'll tell you back. Because when we try to test it with the limited our mission requirements, we wanted to iterate through multiple models. and we found which was closer. And also when semantic chunking, so here when we try those models, we figured out that the ones with the dog, every model is able to chunk it together. But for the back propagation and the so these three, everything was able to chunk it together, but for the back propagation and attention, they were not able to. They were not able to do it. But we found another model which was able to do that all. So this is 16 tokens, right? Basically, if you see this one. And when we tried to chunk, the other models were coming close to 12, 13 out of them semantic chunks. But the model which we used, it came back to 7 tokens. So it was able to club this together and this one. But we did not use that. It was just for the test purposes. Then we go, yeah. Then we built a semantic chunk parser. So what we did, so this is what I said. I tried all these models, we tried it. And out of this, one which we have the BG large, that was the best one. And for that, just one word of caution is then when you are initializing it, make sure the device is CPU, or else in your local laptop, it would get, memory consumption would be there. So we couldn't do that. So we had to do a device equal to CPU.
No, we,
5, we tried them testing. What we figured out was this was the most efficient for a laptop, paraphrase, because it's a lightweight one, but it was not close to the chunking embedding capacity of this one. So this model is like this is the Beijing one, as Asif mentioned last time. So it is 100, it could semantically chunk between passages of 100 languages. So yeah, but it is heavyweight, I'll caution. In my mission for the indexing part, it took like brute force. First I had to do that. It was close to 2 to 3 hours. Mine is not a, for him, he has a M1, M2, M3 chips. It is like 30, 40 minutes. Mine is a Mac on Intel. It takes 2.5, 3 hours. Oh, wow.
My machine is crashed.
For his machine was even lesser than that. He
No,
couldn't even
very
load the model. He couldn't even load the model. So Asif, what we did was, you said last time a 0.4 is a good score in chunking. So we made it to 0.6 as the benchmark similarity score. And again, this is also something maybe if we do in GPU, we don't have to do it, I believe, because I had to do batch encodings. At one at a time, my machine just crashes. So what I did was in a batches of 500, I had to do the encodings, right? So here I pass the brute force chunk paragraphs list, right? So this gets embedded and we save them. And this is the batch. So based on the batches increment, we just encode it and then we stack them together and pass it back. Yes. That I'll commit later. That is only on the retrieval part. Retrieval part and the embeddings alone, right? So this is the actual part, right? What we do here is that paragraph embeddings we have already batch encoding. So we do a semantic chunks. We initialize a list which will contain the tokens. So what we did was we made use of the cosine similarity of the brute force paragraph embedding. So what it does is it provides you a matrix on it which it compares against each other and builds a score. So we will do the iterate through the paragraph list, compare the previous paras embedding with the current embedding, and it's not 0.4, it is 0.6 during the time. So 0.6 if it is there, what I do is, for example, if you see here, this is the one where I do a similarity matrix between the previous element and the current element in the iteration. And if the score is greater than that, thank you.
You need to put it in the GitHub, right?
Yeah. Oh my God. Okay.
That's okay.
One second.
But your machine is frozen. Looks like.
No. Machine is not frozen. 1 second. Yeah. It's good now. So I append them based on each of them, iterate through their embeddings. And if there is a score of that, they gets into one chunk, right? You're just adding it. And then, so these come, and here again, we have to do, because these comes in within appends. So we'll have to flatten them so that they comes into a together part. That is what I do here. And that's it. So you got the semantic chunks, right? So where what we fed was close to 49. It came out 27K around chunks, related one. Now, let me go to the actual one where we do the, yeah. Yeah. So the list is like you have a list of lists. From that, you build a list of strings. And that's it. And this is the SQLite. So what we did was we created a table with the vector embeddings and everything. And we had some utility methods where we write it to the database. And then for retrieval part, so we are going to retrieve only for the top 3 query results, basically the chunk IDs. Yes.
Translated from the.
Okay. Uh-huh. Nested exception. Okay. Exception at the top and then. Oh, okay. Got it. Yes. Got it. Got it. Hello? I'm sorry. Maybe I was away. Oh, man. Sorry. Where was it? Mute.
But nobody tell that. Like, for remote people, there is an issue. But it's
So let's,
recorded.
no. It is being recorded, all right. Guys, those of you who are remote, you can't hear it, is it?
No, we can hear you.
So then what is the issue?
No, now I could hear you, but maybe if the gentleman could come and say, yeah, I mean, it shouldn't matter, so.
Oh, yeah, you have to be close to the
Oh,
microphone.
sorry.
Yeah,
Yeah.
be much closer.
I'm really sorry about that. Are you able to hear me now?
Yes, thank you.
Okay. Thanks, Asif. So we were talking about the SQLite utility module. So it has functions to load. And this is the retrieval part, which we'll be using against. Yes, Mandeep. Uh-huh. Correct. Percent similarity. Yes. Yeah. Correct. No, again, it goes to the next element, right? It is a loop.
Yeah, where we would specify that how many you are looking for, right?
Yes.
That goes with that, let's say if you say 3,
Yeah.
that goes up to the 3 after that would come out. So
Okay, that's like in parameters.
Yeah, exactly.
in it
Then
is,
you extract those,
then it will go everywhere. That
it goes to the next one.
Yeah.
But you remove it from that.
Yeah. So in the memory. But finally, you get it, everything chunks into that list.
yes, it
Okay.
would specify the
Yeah,
how many
yeah,
times
exactly.
how many times it has to match.
Okay.
Top 3, top 4, top 5.
So this data frame retrieval part. So this is like where we get for example, once the search has been actually done, right? For us, we limited to 3. We can, at the max, it can go to 10 searches, right? Those chunk IDs will come in so that from the database, you retrieve only those records, right? And then you display that. So this is the SQLite utility. And next, I will go to the actual part, which is the one more back. Yeah. So this is the actual semantic search module. So here what we do is, so I use the same model which I used for semantic chunking. And this is the one which will be that first part as part of the indexing, right? Where we build the SQLite data store. Once the semantic chunks is done, then we save them to, if you see here, we get this, we call the chunk in data, we got the chunk list, and then we build the data dictionary. which contains the chunk ID list, document ID, vector embeddings, and everything. And then we save this to, before saving to the database, what I do is I save it to the pickle so that I have a cache readily available. Then we save it to the database, right? And then, yes, although complete everything for all the 27,000 tokens, right? And display search results, runtime, you get the query. And in the query, you compare it against the embedding list. If you see here, this is the one cache, right? You read it from pickle and then you get it. And then you retrieve the rank, score, and chunk IDs list. And then you connect to the database, get the data, and then add it to the data frame. That's it. Yeah, here, util.semantic search, you would see. Yeah, this is the one. Compare the query with the search corpus. This is a typical models method. We haven't done anything. And then
This is what we're talking about, the top K equal
top
to
K,
three,
yeah,
right?
top K
That
equal to
goes
3.
up to the three
3 of them.
matches.
And then I will go for the UI module, which is the home.py. Yes. Maybe because yeah, exactly. Some that we also saw that. So here, what we do is it's a simple, we get the results back, data frame, and then we load it, right? So coming back, and also I would like to show you what it generated. For example, this is the data model. So this is the pickle file, which will not load, but semantic search, this is the database. You could see that it was a file, right? 650 MB or something. It was like around.
You can see that that's on the stored in the .db file.
Yeah, this is a semantic search, local files to file based. Yeah. So it will not take it just 2 minutes. We'll be able to see the data. Yeah. If you see, these are the chunks. Yeah. If you see in the database, you would be able to see the chunks and the vector embeddings on this side, right? Okay. So now we come to the text. Let me try to do a search on this one. Let's say Hamlet.
Let me know when I can give you the search.
Sure. First, I'll
We tested
do
that.
a warm up.
Last time you asked, right? We tested that.
Yeah. No, but yeah.
You'll ask the same thing again. Oh,
So-
we want to prove that.
So now we'll see that cache really helped it, because this was the moment which I loved it. Earlier, we used to take a nap and come back. Now it is like coming from the pickle. This was the only easier part in terms of retrieval. The training part was like, I mean, basically in our infrastructure, it's a pain. Takes a long time, but maybe one of our teammates, they had M1, M2, M3 chips. At least 30 minutes, they were able to get it back. For us, it is. Yes, Asif, let's put it to test. What's meetings? Me, things. Yeah. Thou, DUST, right? Thou, THOU, thou dost. Oh, again T, right? Protest.
That is converting actually.
Oh,
Types. No, it is type ahead. It's changing.
yeah. What T?
Actually, DOTH, protest,
D.
OTH.
Okay, let me make sure it doesn't change it.
Protest.
Protest. Too much.
What does it say?
What dost thou think? Think, my lord. Dost thou think I have no sin? Thou strikest me thus. Do you think so too? It is in the chunk ID 1758. No, let me check.
You can search it.
Yeah, I'll search this back to. It should be
Post
Hotel.
note. Search for it.
got it right. It's Hamlet.
Yeah, right? Yeah. The thing is that
Oh,
the only thing is like that data also, I think we should have taken a little bit which we more understand. We took the Shakespeare one context. That was one thing we found. What we did was
But
we
you are
copy
asking
and
something
pasted.
else.
So you, at least ask you tested that. Because what else it was like, what we are like, what is this? So what we did was like copy one paragraph and say, okay, results are coming. So we are good. But we don't know what is it doing. Yeah. Maybe next time we should do something around
No, we tested
on
with
back
your last
propagation.
query.
Yeah.
Okay.
Sure. Sure. Why not?
Yeah, that we tested.
But it gave me a single line. Let me try that.
You should try YouTube Brutus.
The last.
Last one, right? No, not this one. This home, right?
Yeah, home data.
Yeah.
Where is the screen?
This is the one.
That's
this is the
okay.
Yeah.
What is the one?
Wait.
Thunder or in rain.
Oh, lightning thunder is the last query.
Again, in
Light, thunder or in rain.
lightning, comma, is it?
Or in
Special.
Lightning, comma, thunder, or
Or
in-
rain. Or in rain.
Asif, here it is.
Yeah, which one is it?
A storm with thunder and lightning enter Kent a gentleman. Thunder and enter three witches. First witch. Okay, at least Asif tested.
So, at least you tested. Two is done.
You won't get your certificate for this course
Unless you prove it.
Okay, I think this brings an end. Any questions, folks, in the room or in the remote? Yeah, next is the
Well, that's a good thing I like is the code is very and your the fact that you implemented semantic chunking on your own, thinking through it is a very good idea. It's really cringeworthy. And everything looks good. Just clean up your exceptions a little bit.
Okay.
Because see, this is an inference machine. RAG is an inference machine.
Okay.
Which means that you'll be taking traffic
Oh,
at scale.
okay.
And at some point, once I give you my machines, on that, launch it.
Sure.
And then pound it with at least 20 concurrent requests.
Got it.
And see how well your system
That's-
does.
that's our
20 users
idea.
Concurrently hit it.
Okay. Sounds great. Anyone in the remote, do you have a question? I1 AI, hyphen AI, I1 hyphen AI. Yes.
Hopefully,
Yeah, they get the
you want to
machine.
deploy that.
In fact,
into
it's the
that
best machine first, so that team gets the best
machine.
machine.
Yeah, we will
Thank
deploy
you.
for them.
Hmm?
Our goal is to deploy.
Your machine is ready, actually.
Okay. Thanks, everyone.
Thank you.
So meet me at some point.
Thank you.
I'll give you the tail scale and so forth.
Yeah.
Thank you.
Any break time will meet or break time will meet?
But you're going, right?
We are going to now for a break time.
Hey, come back tomorrow. But I mean,
At
any
least
other
if we
day.
have the
Tuesday.
mission that we can try it for,
I'll send you the credentials.
no need to be here.
One of you will have to come just to install. tail
Yeah,
scale.
that's what I thought.
Or what I'll do is temporarily I'll put you on my tail scale and then you can
I
create
have
your own tail
my
scale.
thing ID, so I can
Okay.
rename it. I can give that login. I created a specific for this one.
Okay, good. Very good. All right, guys, that was